In this question, you're given the equation x square minus mx plus 1 is equal to 0. So you have an unknown as the coefficient of x. Obviously, the roots of this equation depends on the value of m. Now, I want both the roots of this equation to be less than unity, that is less than 1. So you have to find the range of m. So let us write the conditions that we have so that both roots are less than 1. So let us also draw the graph. You'll understand the conditions very easily. So this is 1. Both roots have to be less than 1. That means the graph, my graph has to be like this. It should intersect the x-axis 2 times before 1. So what are the conditions which ensure this? The first condition is discriminant is greater than or equal to 0. Discriminant has to be positive so that you get real roots first. And next, the x coordinate of the vertex has to be less than 1. It is minus b by 2a has to be less than 1. Third, what's the next condition? Before the graph reaches the value of 1, it has to rise up. That means f of 1 has to be greater than 0. And we have seen that these two conditions can be applied on the original equation. It doesn't really matter whether the leading coefficient is positive or negative. So these two conditions are always valid. And this condition is valid only in the transformed equation. It is only if the leading coefficient is positive. So if you observe this equation, the leading coefficient is already positive. So you don't need to transform the equation. So already the condition that the leading coefficient is positive is satisfied. So you can apply all the three conditions on the original equation. So first, discriminant is greater than or equal to 0. B square minus 4ac is greater than or equal to 0. And minus b by 2a minus of minus m by 2 is less than 1. And f of 1 is greater than 0. If you put x is equal to 1, you get 1 minus m plus 1 is greater than 0. Now this condition, m square minus 4 greater than or equal to 0, m lies outside the roots. The roots of m square minus 4 is equal to 0 are plus or minus 2. So m lies outside plus or minus 2. So if you draw the real number line, so the first solution is that m lies outside plus 2 and minus 2. The second condition, m by 2 is less than 1. This implies m less than 2. M is less than 2. So the second condition is this. Second condition is this. Now you go to the third condition, m is less than 2. So this also says that m is less than 2. So you have the same condition here. Now what is the values of m which satisfies all the three conditions? So you can see if m is less than minus 2, all the three conditions are getting satisfied. So that will be the range of m for which both the roots will be less than unity. It is m belongs to minus infinity to minus 2. So this will be the answer to this question. Thank you.